This conference will now be recorded.
Hello.
Hello.
Yeah, this is Ravindra.
Hi, Ravindra. This is Srinivas.
Hi, Srinivas.
Hi. Can you hear? You can hear me, right?
Yeah, yeah, I can hear you.
Okay. Okay.
So, other than us, Srinivas, anybody else in the call? Because
Uh,
here, yeah, here I'm not able to see any
yeah. I think.
participants list.
Yeah. Looks like at this point there is no one.
Okay, so then we'll start now.
Sure.
Yeah, so first let me introduce myself. So this is Ravindra. So I have overall 8 years of experience in IT and so working on the most of the technologies related to the Java, Spring Boot, microservices, and the cloud. So I've been working on the microservice and cloud from last 4 years. So that's all about myself. So if you can brief introduce yourself and what is your expectations, so that would be great to understand.
Right. Yeah. I mean, I'm Srinivas. Actually, I have around 12 years of experience in
Okay.
predominantly in data warehousing, and recently I started working on big data and cloud. So I'm more interested in learning the microservices, and the developing and building RESTful web services. So though I know in the beginning of my career I worked on Java, but recently, last couple of years I haven't got a chance to work on Java.
Okay, got it.
Yeah. Yeah, but with as clouds is picking up well, I'm little bit more interested in learning it for my personal interest.
Okay, got it.
So,
Yeah.
so I mean, my basic question is, to learn microservices, what are the prerequisites?
Yeah, sure. Yeah. So, so if you want to learn on microservices, so if you know Java, so that will
Mhm.
be great because so I'm teaching on the Java microservices, so not on any other microservices. So, and also if you have some basic knowledge on Spring or and web services, so that will be added advantage.
Okay. So, I mean, my other question is actually I'm comfortable with Python. So, I mean, can we design microservices with Python, or we need to learn Java?
Python, so even I don't know Python, so
Mhm.
I'll teach only on Java related microservices, so development and architectural part.
Okay. Okay.
So are you looking for Python related microservices?
I mean, not specifically, the first thing is more from an architectural perspective. And yes,
Okay.
mostly from the development perspective. I mean, I don't know much about Spring, but still, I can spend some time and I can learn Spring.
Yeah, so I will be teaching whatever is required for the Spring. Everything is not required here, so we need
Mm-hmm.
to only the core model. So what is the dependency injection and all. So other dependency injection and auto varying. So other than that, we don't require anything. So generally in core Java, so how we used to create the objects and all. So the
Mm-hmm.
same thing how we can do with the here in the Spring. So without creating an object, so how we are going to get the dependencies. So that is what
Okay.
the uh, in the Spring. So one first, let me go through the high level on the microservices. So after that, we will
Sure.
discuss. So what is the
Sure.
course? So 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 yeah, I think you must be aware. So on the microservices. So microservices means generally people will think it is very smaller services. So that's the reason the name is a microservices. It is not like them. It may be the smaller services, but it should have some business context. So again, it shouldn't be a tightly coupled. So each business context we can have one microservice. So in the real time, so generally the monolithic applications was when you are deploying in a cloud environment or even their own on their own premises. So it's very difficult to scale up because the monolithic application so will be writing all the code, the backend, business logic, front end, everything in this one part of one bundle. So it may be var or EF file. So when you're deploying the cloud, what will happen? Say, let's say we don't need to scale up the entire application in real time. Let's say when you go to the e-commerce or any e-commerce or any application, so mostly e-commerce. So what will happen? Let's say you want to. Generally, people will be browsing, but only few people will be buying the product. So what will happen? So when you just browse the product, so they are not going to make any payment or any even they will not add it to the cart also. Some people will even will add it to the cart, but they will not go for the payment. So why we need to scale up the entire application? So just only few services or a few functionalities only. So we need to scale up. So that's the reason the microservice has come up with the solution. I mean the Netflix Eureka, and there is a one more microservice architecture. So that is a console. So what we will do is so instead of doing all these things, so we can have different kind of services like in SOA. So we can write different services and we need to communicate it with each other. Even that kind of implementation was there already. But the main advantage here, so let's say you have some 100 microservices. So if you want to communicate each other services, so let's say in real time, so we will always change some host details and port details and all. So that is not going to work in the real time because when you deploy in the cloud, you may be changing your host details and all for some security reasons and all. So again, it's very difficult. So that's the reason we use the microservice architecture. Okay, so let
Okay.
me so open the paint and show you so how it is going to work with the microservice. So generally, yeah, when you take so the monolithic application, uh, so this is so here if you see, let's just assume this is in some e-commerce application. So here what we will do, we have a front end layer and we have a back end and we have a business logic, everything, right? All the processing, business, everything. So when you deploy in the cloud environment, so since we have all the content in one var file or ER file, this is just assume a var file. So web related application or enterprise application. So when you deploy in the cloud, so here unnecessarily we are going to pay money because we don't need to scale up entire application. So it may, when you take any e-commerce or any healthcare application, so the application will be very huge, and if you deploy the entire application, so we may need to launch many servers. So it is not a single server, few servers. So because of this thing. So when you go for the microservice architecture, so what we will do, even before the microservices, also we have some service to service communication architecture. So this is like just say one service. So each service has some business context. So otherwise we cannot write a very small services. So let's say this is just I think this is a for microservices also we have some service to service communication. So you can also so everyone aware of that already. So that's still people are thinking. So we even before microservice also we are communicating service to service. So why can't we say that is a microservice? No, this is not actually microservice because still this is somewhat it's tightly coupled because let's say this is some product service and this is a cart service. So generally, people will add all the products to the cart. So the cart is depending on the product, right? So
Right.
Generally, yeah. So here in real time, what we need to have some communication between these two services. What generally we do, so we will, so we need to, we should know what is this particular service host and the port, right? So let's say this is deploying in sorry, HTTP local host, so 8080 slash product. So the card should know this particular URL. So if you don't know this URL, it's very difficult again. So that's the reason. So we always give all these URL details, everything in the normal service to service communication. So this is also sometimes it will create a problem because we are hard coding all these details in the application. It may not be the hard code, it may can give you the property also, but still it is like a, we are really always depending on the host and port. So
Mhm.
that's the reason the Netflix they have come up with a solution. So why we need to go for service to service communication, and we have a concept called a registry. So this is a registry service, and these are all our microservices. You may have some 100 or 500. So max we can have 1,000 microservices. Okay, so we cannot go beyond 1,000 microservices, but even in the real time that will not happen. So if you are writing the more than 1,000 applications, so our application is not a proper application. So here, uh, so this particular service will communicate here. Okay, so we need to register all the services, and even this service also we need to register. Mhm. So
Hello.
okay,
Hello.
yeah, can you hear me?
Yeah, now I can hear you.
Okay, so what I'm saying is, so this is the registry service. Okay,
Hmm.
and these two are the microservices. So we have one product service and we have our card service. So instead of communicating directly from the card to product, so what we will do, we will register all our services here, and just by using the service name, we can directly get it in the card. So now we don't need to give the what is the host and port. I mean that URL we don't need to give. So we just need the service name. What is the service is registered in the registry service. Even the same way, count also will be registered here. If any other service want to consume this particular service, so it's a kind of a producer consumer base. So we will directly give the that particular service name, and we will get all the details. So just assume, so this particular product and service card details we are deploying in the cloud environment. So let's say only more people are hitting this product, so not the cart. So when the server capacity is full, so what we will do in the cloud? So we have auto load balancer, and even we have auto scaling group. So we need to create the auto scaling. So if you are already aware of the cloud, so we
Yeah.
need to create the auto scaling group, and we can launch so n number of instances. So we need to define the what is the minimum instances that we need to launch, and what is the max instances that we need to launch. So we need to define all this setup. So now what will happen is,
Can
so
I ask one question here?
sure, yeah,
Let's say, suppose if I just want to, auto scale the product service. So whenever we build these services, right? So product is
okay.
deployed on one instance and cart is deployed on probably multiple instances. Like, are these services are generally distributed, or like how we will deploy these services?
Yeah, these services are distributed. So,
Okay.
so here we have some features in in the microservices. So we call as a ribbon. Okay, so the load balancer client. So the load balancer client will take care of the. So let's say the product is deployed in multiple instances. So the cart is deployed in only one instance. So since the cart is consuming, so the cart should know which the product it has. I mean, which product instance it has to fetch the details. So the load balancer client will take care of all these things. So even though we have in the cloud these kind of things, so again we have a client-side load balancer.
Okay. Okay.
So these are the features we have in the microservice architecture. So here we not need to depend on the entire host and all. So that is the main benefit here. So all the services will be registered in the registry service. So just by using the service name only, we will fetch all the service related details.
Okay.
So this is high level the microservice architecture, and we have so many features in the microservice. So generally, when you deploy in the cloud, all these services will provide so many layers of security. So each endpoint also we will authenticate. We need to authenticate whether valid is there or not. So if it's valid is there, only we will allow this particular service. Otherwise, we are not going to allow. So that is one layer of security. Another layer, anyway, we are going to deploy in the private cloud, so nobody can access these URLs, this product and cart. So what we will do? So we will have some gateways. So we call it the API gateway. So in microservice, we have Joule API gateway. So when any request comes from any mobile application or web, so the request will go to the Joule API gateway. So if you don't have API gateway, so that the request will directly go to the product and cart. So that's the reason we will provide so many layers of security, just for security purpose only. So this will talk to the API gateway. Okay. So this is like a single entry point instead of having the multiple entry points. So it may be sometimes you may miss the security and all. So that's the reason. So we have this API gateways, and all the requests will come to this API gateway. API gateway will talk to this registry and route this particular request to the relevant service. Let's say if this particular person want details on the product, it will go. This request will be routed to the product, and it will give the details back to the user. Okay. So
Oh,
same way, it may communicate to cart or fetch all the details and respond back to the user. So that is what the API gateway generally we have in the cloud. So
okay.
now just let me go through the course content and so what are the issues and the microservices. Only the thing is challenging is the logging part, and so and also we should have some proper monitoring tools. Otherwise, it's very difficult to track it. So when you develop all the applications, so we should have some proper logging mechanism, and also
Okay.
status and all. So that is very much required. So if any one service goes down, so the entire application may go down. But we have again some fallback scenarios also. So if you want to go for fallback, we can implement the fallback also. Yeah. So here, uh, since you are not aware of the Spring and all, but most of the any batch, at least one or two persons are not aware of the Spring request, Spring and all. So that's the reason I'm teaching one class. I mean, 1 hour the dependency injection related stuff. I mean, first why we need the core Java, why we need to create an object, and in the Spring why we need to create the beans and how we are injecting the beans and all. So that is what I'll teach on the Spring, and introduction to the Spring Boot, and the Spring Boot. I'll be teaching all the concepts because without Spring Boot you cannot work on the microservice development. Okay.
Okay.
So that is what I'll be teaching on the microservice, sorry, Spring Boot. And in the Spring Boot, the main thing is what is the auto configuration management, and what are the dev tools, and what is how embedded servers works in the Spring Boot application. Generally, we will deploy all the applications in any external server. So we will not have any embedded server. But here in case of Spring Boot, by default, they are giving the embedded Tomcat server. So how it is, how it works and all. So we will define. We will talk about that. And also deploying our applications in external Tomcat server, but mostly nobody will deploy in external Tomcat server because inbuilt Spring Boot is given the Tomcat container. So generally nobody will define. So if you still think you want to deploy it, so we can deploy in the external server, any of the server, not only Tomcat.
But generally,
Okay.
this external the Tomcat server is not used for enterprise applications, right? Generally, people use WebSphere or
Yeah,
some other.
yeah, in the Spring Boot application, they don't use even WebSphere also. They will use the Tomcat only.
Okay, okay,
Yeah, so that is here main thing in the I mean in the microservice applications. So they
okay,
don't use any other server. So here and again Spring Boot with SQL SQL database. So how we are going to connect to the different databases. So I'll talk about both Mongo and Dynamo database, and also
okay,
how we can handle the exceptions. So this is very much important in the microservice applications. So how we are going to handle all the exceptions. So that is the one thing. And Spring REST versioning. And when I go to Google APIs and all, you will find versions V1, V2 like that. So these are the different versions. So how we can maintain the different versions in Spring Boot and RESTful services. So, and also monolithic applications. So we just discussed very basis the monolithic applications. So that also we are going to talk about in detail challenges in monolithic and what is a microservice and what are the difference between microservice and monolithic architecture, and also 12-factor app. So when you are implementing any microservice, so always we need to see what are the 12 factors that we need to consider when you are implementing a microservice application. So Lombok is just a dependency to to simplify the code because always developers used to the entity classes or model classes, they will create so many variables and create a set of indicators. So how the Lombok will help us to not to create any set of indicators. So that will take care of the compiler. So that also we will talk about how to use it in the application. And from 16th onwards, this is purely related to the microservice architecture. So before that, all are related to the Spring Boot and all. So it will take at least three weekend classes. I mean, three means almost some 8 to 9 hours. That's
okay.
almost more than 10 hours, I can say.
Hmm.
Um, yeah. So from the 16th onwards, it's completely related to the microservice. So the microservice registration, so how the registration works, and everything is a practical. It is not theoretical. So I will show all the live examples. So and also microservice interprocess communication. And before that, we will talk about how we can communicate service to service without using the microservice. And later we will come to the microservice using the microservice how we are going to communicate. So the
Okay,
next one is the load balancer client. I was talking about the load balancer. It's a ribbon. So it's 18th and 19th is the same. So by mistake I added two as the 2 points. Otherwise it is same. The concept is same. And the Fiend client also we will talk about, and the API gateways. And also since let's say we have 100 microservices, if you want to change some properties and all, generally we need to go to that particular service and change it. So that is a tedious task. So that's the reason that a config server will take care of all this, the configurations and other stuff. So we have two different approaches. So one is the native, means in the local itself we can maintain properties and we can handle it. But in real time, nobody will use the local, and everyone will go with the Git config server. So config server is the GitHub or any Bitbucket or anything. Okay, so next one is the Spring Boot admin server. That is like a monitor application. So we can monitor all our applications by using Spring Boot admin, and also we can handle all the logs as well. And Swagger API, it's a REST API documentation. And also generally everyone knows that the RESTful and differences between RESTful and SOAP based web services. So REST, it will not maintain any state in the server. So then how we are going to measure maintain the cache uh, in the RESTful services. So by using Redis cache, so we can maintain all the caching. And also the bus messaging cloud messaging system using Apache Kafka, and also the microservice security part. So this is a very important OAuth2 and JWT tokens. But if you are using in AWS cloud, we have so many features.
Right.
So yeah, so there is a Cognito service. So that's the reason people are going with the Cognito. So they're not implementing OAuth2 and JWT now. So distributed tracing with the cloud Zipkin and Slip. So how we are going to trace the logs in the distributed environments, and how to use the Docker for microservice application. So I'll show you the how to create the Docker file and how to use that. I mean, how to create an image and run that image in the cloud environment. So there are different ways we can do that. So we have either EC2 also we can directly deploy it, but EC2 is a little costlier. So that's the reason people will go with the Fargate cluster or any other services. Even Elastic Beanstalk also we can deploy it, but those are costlier.
Okay.
So microservice application, yeah, that is what I'll talk about, the cloud deployment, how we can deploy it, and how we need to integrate all these features and deploy in the AWS cloud. So it's mostly related to the its development and architecture, but everyone in the team will not get the chance to work on all these features because so only once we will define all these services. The remaining is coding is it will be up to the 15th point. So remaining all code will be in the Spring Boot. So only the architecture is microservices. So how we are going to define the architecture. So that is very much required here. So any questions, Srinivas?
Yeah, actually, one more thing I have been hearing recently,
Mhm.
Docker is basically for more of a containerization of the microservices, right?
Right.
And
Yeah.
how there is one more, the tool I had, Kubernetes, how it is related to
Kubernetes.
microservices and, the Docker.
Okay. Kubernetes it will be used for the distributed environment. So even I'm not, I don't have much details on the Kubernetes, but I will try to, explain the Kubernetes as well.
Okay.
So
I
because in
mean,
the current
the
application,
thing. Yeah, the
yeah,
thing what I am trying to understand is, like there is one more concept nowadays I've been hearing about DevOps, right?
yeah, right,
So, like the microservices, let's say suppose if I want to use, like in the process of like continuous delivery and continuous integration kind of thing, right?
yeah, yes, yes.
So, yeah, so like are there any kind of DevOps tools, using which we can automate this process, the
Yeah.
microservices?
So in the AWS we have a features called pipeline. So
Uh-huh.
we will create a pipeline in the AWS itself. So that will take care of the continuous integration. So we just
Okay.
need to create the pipeline. So we just need to configure what is our Git server, and what we need to do once we integrate with the Git repository. What where we need to do the build and deployment. So all these steps we need to configure in the code pipeline. So that will take care of everything. So build and deployment.
Okay. Okay.
Yeah.
Yeah, I think,
So
some
yeah, I
of
will
these
be.
terms I'm not
Yeah.
much, very much,
Okay.
very much aware of it because I'm more from, the data background.
Okay.
I worked on mostly, shell scripting and Python, and now
Okay.
I'm working on big data.
Okay.
So I think I need to pick up some of these things, especially I think the Spring Boot.
Yeah. Right.
So if I change a programming language, right? Because let's say from Java, if I change to maybe Python or maybe some other language, how
Okay.
drastically the tools whatever you mentioned here are going to change. Like for example, if I look at 26, right? Redis cache.
Yeah. Right. Right. Yeah.
right? Or maybe the authentication, or like on the row number 29, you mentioned distributed tracing with Spring Cloud, Zipkin, and Sleuth. So how these
Yeah.
tools are going to change if the programming language changes?
Yeah. So here, let's say here Jipkin is the server and Sleth is the client. So let's say the Jipkin you implemented in a different language. Let's say the Python,
Right.
and the Sleth can be implemented in Java.
Mm-hmm.
So that will not create any issue. And say only the programming language you are changing, but underline I mean whatever the dependencies we are using the same. So that is not going to change anything. So whenever there is any change in these things, I mean the dependencies on the, so we just need to modify. Otherwise, it will not create any issue. So here, since it is a microservice architecture, so and these are different services, so there is no technology constraint. Also, we can use on any technology. So one service can be technology, one service can be one technology, and another service can be another technology. So since here all are the RESTful services, so we just need to produce some data.
Mm-hmm. Okay.
So all of these are all the features, and in the PPT nothing will be there. So whatever we talked about, the same thing will
Right.
be there in the PPT. So generally I don't show you the PPTs and all. So at the end
Okay.
I will
Okay.
be showing. Yeah. So what are the challenges just to understand?
Okay.
So
I
what are the
think.
difference between? Yeah. So any other questions, Srinivas?
No, no, no. I don't have any other questions.
Okay, fine. Yeah. Yeah. Thanks, Srinivas. So you can
Okay.
just
Yeah.
update it to the mind matrix. Okay.
Sure. Yep.
Yeah. Yeah. Thank you.
Okay. Yep. Thank you. Bye.